Hello everyone, in this video I'm going to show you how to test the stator in your motorcycle engine. So the stator is located underneath the alternator cover on the left hand side of this particular engine. Now the stator works with the rotor to form the alternator on the motorcycle engine, and the role of the alternator is essentially to supply power to run the motorcycle and recharge the battery. So if you find that the battery on your motorcycle is dying, it's not getting recharged, then there is a number of tests which I have talked about in another video that you can do on the regulator rectifier to check if the regulator rectifier is the cause of the issue. If you determine that the regulator rectifier is working as it should, then the next thing that you move on to is checking the stator. Now, also, if you find that the regulator rectifier is actually bad, you should still test your stator as well, because the two components can go bad at the same time. So the way we test the stator is we disconnect it from the regulator rectifier. So this particular stator has been disconnected from the regulator rectifier, and I have also taken the little electrical connections. They're installed in this little plug. Okay, so the little electrical connections will be installed in this little plastic insulated plug, and that itself will be plugged into the other half of the plug, which connects into the regulator rectifier. So I have taken it out. You don't have to take it out. I have taken it out just to make it a little bit easier so you can see what's going on. And it also makes it a little bit easier to do the test. If you leave it inside, you'll have to use probes. So it's just easier if I take off that little plug. Now, when I look at the wires that are coming from the stator, okay, so it comes out through here from the stator, and there is 5 wires. So I can see straight away, I don't know what all the wires are for, but I can see straight away that the wires that I am mainly concerned about in terms of checking the charging ability of the stator, and also the ability of the stator to generate alternating current to supply the power to my motorcycle. The wires that I'm looking at are the yellow wires. Now, as you can see, there is only 2 yellow wires on this particular coming from this stator. So this is a 2-phase alternator. On most of the motorcycles that you will come across, particularly the larger CC, you will probably find that there is 3 yellow wires. And in that case, it's a 3-phase alternator. Now, it doesn't really matter. The testing process is going to be exactly the same, except I'm using less wires. So I only have 2 wires to test instead of 3. So the test is quite basic. All I really need is a multimeter to do my test. Okay. Now, my multimeter, I need to set it to test resistance. Okay. So I set it to the little ohm symbol on my multimeter, and I'm just going to set that up here. Turn on the light. Okay. Now, I'm going to show you in a few minutes inside the actual alternator cover. I'm going to show you the stator, and I'm going to explain how it works in a little bit more detail. But to do the test, I just need to take my black lead and my red probe from the multimeter, and I need to just connect them to the yellow wires. So I just picked 2 of the yellow wires. It doesn't matter if there's 3 yellow wires. They're basically the output from all yellow wires from the stator should be exactly the same. The resistance should be exactly the same, and there should be just no difference, okay? So that's why the three of them are yellow and not different colours, because they're all, three of them are basically, should be treated the exact same. That doesn't mean that they're going to be exactly the same, but they should be if they're working properly. So I'm just going to take my black probe and connect it to the first yellow wire, and I'm going to take my red probe and connect it to the other yellow wire, and I'm just going to turn that light just so you can see it for a second. So the reading I'm getting there is 0.9 ohms. So what's important to know here is that before you begin this test, you really need to have taken a look at the service manual for your model of motorcycle, because the specification for the resistance will not be the same for all stators. Each motorcycle model will have its own range of resistance that should be in the stator wires. Now in this one it's 0.9, that's a typical reading, 0.9 ohms. But for example, for my Honda VFR 750, the service manual states that the resistance reading should be anywhere between 0.1 ohms and 1 ohms. If the resistance falls outside those specifications, that's an indication that there is a problem with the stator. Now, let's pretend that this green wire is not a green wire, but it's actually a yellow wire. Okay, so let's say pretend we have a 3-phase alternator. I would then take my test probe and I would just move it around like so, and I should be taking readings on the multimeter. So in this case here, it's giving OL. That means that it's out of limit, the resistance reading. It means that it has infinite resistance. Now if this is expected with this green wire, okay, but if this was a yellow wire, that would be an indication of a problem. That would mean that there is a break in the circuit somewhere. So by a break in the circuit, I mean that current should be able to flow unimpeded. Let's say in this green wire, should be able to go up through the lead into the stator, go around the windings of the stator, and come back out through the yellow wire and come out here. So there should be no break in that circuit. Now if it says OL, that would be an indication of a problem. Okay, and when I go back to here, the other yellow wire where we know it should be good, we get again our resistance is it's 0.9 ohms. 0.9 ohms is quite low. If you get a reading of 0.1 ohms on your multimeter, that is essentially, it's generally as close as you're going to get to zero resistance in really any electrical wire using a common multimeter to do the reading. Now we can switch these terminals around, so we can switch them from one wire to the other. It shouldn't make any difference. There is no polarity in the wires, so current can go in one direction or it can flow in the other direction. It doesn't matter. So we still get 0.9. That's what we would expect. Okay. Now the next reading that we can do is to test that the stator is isolated from the negative terminal of the battery. Now obviously this engine is not connected to the negative terminal of the battery, or it's outside of the motorcycle. That doesn't matter. I can still do my test because the engine, the frame, will be connected to the negative terminal of the battery. So any reading you get on the negative terminal of the battery, you should still get that reading on the engine of the motorcycle. So I choose a part of the motorcycle engine where I know that there is bare metal. There is some paint on this side, but on this side in here it's bare metal. So I make sure that I can connect it in here. I could choose a bolt, or I could choose any other area on the engine that I know is bare metal that is essentially connected or has continuity with the negative terminal of the battery. Now in this case here, we're getting a reading of OL. So that means that there is infinite resistance. That's, first of all, that's what we expect. And again, it doesn't matter if I take this off, black probe, connect it to the engine, and put the red on here, I should still get the same reading. It doesn't matter, it's not polarity dependent. Now if I take my red probe and I connect it to the other yellow wire, I still get a reading of OL. So it's out of limit. That means that there's infinite resistance. So that means that the wires, the copper wire windings in the stator are isolated from the negative terminal of the battery and from the engine. It means that these wires that connect into the stator are not in contact with any part of the engine. And that is important, because if any of the wires in the stator were in contact with the engine of the motorcycle, that would allow current to leak out. So instead of that current that's generated in the alternator being pumped to the battery through the regulator rectifier, some of that current that's being generated will just leak out through the engine of the motorcycle. Okay, and that will make sense a little bit more when I just open up this regulator, or when I open up this alternator cover and show you the stator and how it actually looks. Now, when you're doing these readings, the other thing that's quite important, I did mention that you have to make sure that you don't try and connect to some part of the engine which is totally painted, because paint is not a good conductor. You want to connect it to bare metal, so something like one of these bolts, like a bolt that's connected on the engine, that is bare metal. But any of these other parts here that are painted, the paint is going to create resistance and it's going to give a false reading. So make sure it's bare metal, because bare metal is a good conductor, whereas paint may not be a good conductor, and it may give a false reading. Now the same goes when we're doing this measurement. When I connect my probe here, the red probe and the black probe from the multimeter to measure the resistance. Okay, when I'm measuring my resistance, don't be put off initially if you get an OL straight away, okay, which it indicates that there is a problem, right? Now looking at these connections are nice and clean. It's nice brass, clear metal. There's no dirt, there's no oil, there's no plastic, there's no residue, there's nothing that would impede or cause resistance when I connect this probe. Okay, so that's why I'm getting a clear reading of 0.9 ohms. What could happen is these terminals can get dirty in the motorcycle over time, and any bits of dirt, oil, residue on these terminals, or the connections could come loose. That could result in a false reading. So you could stick these on and you could come up with a reading. Let's say this is my yellow wire, this one here, and I get an OL and I go, right, there's something wrong with my stator. Don't presume that that is the case. What you need to do is make sure you get a little wire brush and clean off the connections. Make sure that they're nice and clean, that they're very, you can see shiny bare metal before you do these readings, okay? Because again, you will get false negatives or false readings. Basically, you'll get only a small amount of dirt or oil or residue on these terminals of these wires will give a false reading, will increase the resistivity and make it seem as if your alternator is not working. Now, if you do get these sort of false reading, it's also an indication that either you have to clean these little connections or you maybe have to replace them because they're just too far gone. Now, this scenario has happened on my own Honda Shadow. So here we have some connections that I actually cut out. So they basically, this is just one of them here, and if we just compare the two of them, you can see that one of them that's in my finger, in my glove, I've cut it off, I cut it out of the wire, or I broke it off. Okay, this came off my Honda Shadow. This one here, you can see it is black, and it's not shiny the way this one is. So this brand new one is nice and clean. Okay, and then if we also compare this one here, which was the male connector, which connected in here, right? If I just leave that down actually for a minute. If I compare this one, right, you can see there's a nice little nice clean insulator. It's nicely professionally done. Let's take a look at the insulator on that came off my connector from my Honda Shadow. It's in absolute bits. It's all melted. The insulator itself, the yellow wire, which you can see at the end here, is all broken and burst. And I can see the copper wire coming through, which I should not be able to see. Right? So you need to watch out for these sort of bad connections. These cause the problems with the stator, okay? And they also cause the problems with the regulator rectifier. So what's happened here is that over time the dirt has built up and has increased the resistance between these two connectors, even though they were connected. And that caused them to heat up, and it caused the insulator to melt, and it's deposited all over these connectors, and that has increased the resistance even further, to the point where when I went to do the measurement, I was getting very high resistance. Now when I cut these off and I put on new connectors, let's say like these on my Honda Shadow, the resistance of my stator wires all of a sudden came back into tolerance. So be careful of connectors like this. They're going to give false readings because of this residue of dirt and burnt plastic. Okay. And then the next thing to talk about is, why would a stator go bad? Well, the reason that a stator goes bad is because what it essentially is an electron pump, or a current pump. So it's basically pumping or creating current through a moving magnetic field around coils of wire. It induces a current which is pumped out from the stator through these yellow wires, through the regulator rectifier, and onto the battery, and onto the power of the rest of the motorcycle. Okay. Now, if these connectors go bad and the current can't flow, then the current is still being pumped, but it's not getting to the battery, it's not getting to power the motorcycle. And what happens is that current energy, or that electrical energy, is converted into heat energy in the stator, and it causes the copper wire windings to heat up over time, and it causes the insulator in the stator to melt, and it also causes these little electrical connections. They will still conduct some current, but what will happen is they will create resistance, and what will happen is you'll start getting arcing. So basically it's a little bit like a spark plug. So the current is not, the metal on metal is not happening anymore. And there's a tiny little microscopic separation between the two pieces of metal caused by all the dirt or whatever, and current begins jumping between the little electrical connections, and it begins to heat up. So these little electrical connections, they heat up over time because of resistance, because of all that dirt. And this is the result. This is again off my Honda Shadow. This is a plastic connector. So here's what a good plastic connector looks like. It's a little bit dirty, but it's in good shape. This one here, it's all melted. It's all melted here. It's all melted there, melted there. It's just, you can see the burning on this inside. You can see it's all burnt where it was melting, and that's due to these little connections heating up. They weren't functioning properly, and when that current is not flowing properly, it can be building up in the stator, particularly when this stops conducting electricity completely. That induced current turns into heat energy because it has nowhere else to go, and it causes the insulator on the stator to burn and disintegrate, and then the stator becomes pretty much useless. Okay, so let's go and open up our stator and take a look at it. So this engine has some oil in it, which I don't want to spill out, so I'm just going to turn it up like so. Turn it on its side. Now I can just take off my alternator cover. Okay. Let me just move that engine a little out of the way. Okay. So here we can see the stator. Okay. And here you can see the copper colour is the copper wire windings. So there's coils of wire. And it's the moving magnetic field in the rotor. It's rotating around these wire windings in the stator. And that's what induces the current, the alternating current, to flow or be generated by the alternator. Now, if the stator is bad, for this one anyway, I would just remove these three little bolts which hold on this stator, and I would just then take it out and I can put in a new one. Now we can see here there is two little yellow wires here and here. So these are the other ends of these two yellow wires. Okay, and you can see that they are soldered in, they're connected into the stator at these 2 points. So that's where those two yellow wires begin, and this is where they end, just here. Now the copper wire windings is basically one length of wire. So let me just get my red lead just to demonstrate this. So basically what's happening here is, what we have here is each of these coils is basically just a length of copper wire. The wire is insulated, okay, and it's essentially just wrapped around the coil like so. Like so. That's all the coil of a stator is. And then the next coil, it's wrapped around, it moves on and it's wrapped around like so. And then the next coil is going to be the exact same. So we have 1, 2, 3, and it's going to be exactly the same. So I've run out of wire here, but you can see that each coil should be connected to the other. So each of these coils should be connected to each other, right? So there's this wire here, which is connecting each of the coils together. And that's the way it is in each of the coils in this stator. And that's why when we measure the resistance between these 2 points here, it's because it's like measuring the resistance between here and here. Okay, they're all connected into the 3 coils, let's say. So the resistance across this lead should be 0. It doesn't matter if it's wrapped up or just a straight line. That's essentially what we are measuring with a stator. Now the other wires that are here, I can see that there is a black and red wire, which is soldered in, connected in here, and it is connected to this coil here. Now this coil looks a little bit different. This is an exciter coil, so this coil powers the ignition of this particular motorcycle engine. You will not see this particular coil in all motorcycle engines. On a lot of the motorcycles, all the coils will look like this. There will be no exciter coil. So this one is it's rare enough nowadays that you would have an exciter coil. It's an old design, I suppose. And then so that's that black wire here, okay? Now this coil here is actually grounded to the frame of the engine. And I can actually measure the resistance between here and the actual engine. the metal of the casing of the engine, and I can find that there is actually a small resistance. It's not very large, but current can still flow, okay? And that's just the way the exciter coil works. It actually has conductivity with it and the casing of the engine, or the negative terminal of the battery. But there should be no connectivity, so let's just do a quick check. Measure resistance again. Alright, so I'm going to measure between this black wire and this yellow wire, and we get OL, which is out of resistance, and then the same with the other yellow wire. So the other yellow wire and the black wire, it's out of OL, which means there's infinite resistance. So that exciter coil, which means that this exciter coil is a separate coil of wire. So it is connected to the casing of the engine, and it is connected to this black wire, but it is not connected into the coils of wire. The wire that is wound around all these coils here is not wound around this one here. It's a separate coil of wire, or separate circuit. Now, all these measurements that I've shown you are all conducted when the engine or the motorcycle is not running. There is one measurement that you can do when the engine is running, and to do that you need to be able to measure either alternating voltage, which is just the V with a little curvy symbol beside it. So there is DC voltage here, and then we have AC voltage. So you need to be able to measure either AC voltage or AC current. Not all multimeters can measure AC current. This particular one is a little bit more advanced. It can measure AC current, or they may not be able to measure AC current to a very high level. Now this one I can measure both, right? And generally which one you measure depends on the service manual, because the service manual for your motorcycle will specify that when the engine is running, the alternator should be generating a minimum AC voltage, or it may specify that the engine or the alternator should be generating a minimum alternating current, right? So which you measure depends on what is specified in the service manual. And what you do is, it's a bit like taking two leads here. The black probe goes on one yellow, and then the red probe goes on one yellow, and the black probe goes on the other yellow wire. Okay, you would set it to measure voltage first of all. So you will then turn on the motorcycle, and you should see that there is a voltage reading on the multimeter, and that AC voltage reading should correspond to the it'll probably specify that the minimum voltage or AC voltage output at a particular rev range. So you will rev the motorcycle to that particular rev range and check that the voltage reading is not below that minimum specification in the service manual. So that's essentially how you would measure the AC voltage output. If you were measuring the AC current, you would set it to measure AC current before you turn on the motorcycle, and then you would turn on the motorcycle, and then you should see that the AC current output at a particular rev range matches up to what's in the service manual. Now you would then switch between the wires. So you would then go from, again, this is only a two-phase alternator, so I can only have two wires, but let's say this green wire is a yellow wire. You would then measure it across this other wire, between that yellow wire and this yellow wire, and then you would switch it and measure between this wire and that wire, and the reading across all the wires should be either exactly the same or very close. Again, if you see a difference in the output between the wires, then that's an indication that there is possibly an issue with the circuit or maybe one of the wires. Now, it doesn't necessarily mean that there is a problem with the alternator itself. There could be a problem with the wires from here all the way up through that connect into the alternator. So your alternator could be perfectly fine. And I'll show you a picture here of some wires, the yellow wires, that get frayed over time. So it's either the heat in the wires has destroyed the yellow insulator, or the yellow insulator has just disintegrated over time. Now, I generally don't think these insulators, for most of the mainstream motorcycle brands, deteriorate really over time. They will only deteriorate if they're subjected to extreme temperatures or weather conditions, I would imagine. So generally it's going to be the heat in the wires that causes these yellow wires to disintegrate. So your stator could be perfectly fine, but you could have just frayed insulator on the wires. If your stator is bad, if it has suffered from heat, what happens is that the copper wire windings, when the stator heats up, it destroys the insulator, and you will actually see it. The insulator will become burnt, or the stator will look burnt. It'll actually be quite obvious. You will see discoloration, or you will see burning on the stator. And here's a picture of a stator which has damage to it. So that's it. That's how you test the stator in a motorcycle. Hopefully you found this useful and you're able to use the knowledge to apply to checking the stator on your own motorcycle.